G'day guys, what I'm just going to go through this afternoon is I'm just going to recap some of the function notation and some of the function stuff that we've gone through. So I'm just going to call this function recap. So everything on this Cartesian plane, on this coordinate axis, is defined as a function, and what you notice is that we have pieces. So we've got this piece here. So if we were to define this function, it was made up of 1, 2, 3, 1, 2, 3, 4, and 5 pieces. So let's have a look at what some of these pieces might look like. So when x is less than -5, we have the line f of x is equal to -2. So on this axis we have output, and on this axis we have input. So think of it like your x and your y. It's the same thing, it's just this new function notation. So this function is -2 when x is less than -5. So from all of these values back, it's equal to -2. This function here, this is x plus 4 has a gradient of 1 and it's been moved up 4, and that's for all the values of x greater than or equal to -5, so equal to -5 all the way through to 1. However, at this point it's undefined, so I probably should have gone to from -5 to -2, strictly less than -2. So from -5 to -2, it's that straight line x plus 4, and then it is equal to 4 when x is equal to 2, -2. So when x is equal to -2, it's actually equal to 4, and then it's x plus 4 again when x is greater than 2, -2, keep dropping that, greater than -2, and less than or equal to 1, because it is actually defined at that point. And then it is it's the quadratic. X has been moved across 3, plus, and it's been moved up 1, and it is defined plus 1. It is defined for all the points where x is less than 4 and greater than or equal to 1. And so I could go through and we could work out every piece, but it's made up of lots of pieces where each piece is only defined in certain domains. But what I want to look at is this function notation. So what is the function when it's evaluated at -5? So when it's evaluated at -5, it is equal to -1. That's its output. When we input -2, what is our output? Well, it would normally have been 2, but we've removed that point, and then we've actually defined the function as 4 at that point. So f of -2 is 4. F of 1, if I put 1 in, we get 5. So ignore all this. You can actually just read off what the function is doing from the graphical representation, if you will. So f of 4, f at 4, well, it's defined as -1 at that point. And f of 5, well, it's defined as 5 at that point. So as you can see, if we put any x value in, we get an output, f of x. And so we've covered similar style stuff a little bit in level 2 calculus, and so now we're building on that, going beyond what's actually happening on the curve and looking at the limits. So what I've got here, hopefully you can see, is what is the limit of the function as we get closer and closer to -5. So as the function gets closer to -5, we get closer to -1 from this side and get closer to -2 from this side. And because it's different from either side, we say undefined limit. the limit is undefined because it's different from it's different from the left and different from the right. What is the limit as we go closer to negative 2? Well, we don't care what happens on negative 2 as such. We only care about what is expected to happen. Like I said, calculus is all about rates of change and what is expected to happen. So what is expected to happen as we get closer to negative 2? Well, from the right we get closer to 2, and from the left we get closer to 2. And so we can say that the limit of f of this function as we get closer to negative 2 is 2. Right, what's the limit of this function as we get closer to 1? Well, from the left we get closer to 5, and from the right we get closer to 5. And so the limit as x goes to 1 of this function, as x gets closer to 1 of this whole function, is 5. And finally, what is the limit of the function as x goes to 5? Well, from this side we get closer and closer to 2, and from this side we get closer and closer to 5. And because the limit is different from the left and right, again we say undefined limit, right? The limit does not exist. So even though when x is 5, it has a value that's assigned to it, the limit doesn't exist because it's different from the left and right. Hopefully that clears up a bit of the confusion around that, and hopefully a worked example helps you out.